So the cloud. AnyLogic Cloud is not as scary as you can see on this slide. I wanted a kind of stylish gray cloud. That's the only reason the cloud is gray here. Okay, so the AnyLogic Cloud, these days, what it is. First, there is public cloud. If you go to cloud.anylogic.com, you will have this interface. It's like YouTube-like interface, and this is where there are a lot of models. And anyone who has any kind of, even a PLE version of AnyLogic can post a model to the public cloud, right? And because anyone can do it, and because every second student kind of does it, there's a lot of trash in AnyLogic Cloud. Trash, I mean like maybe 200 of bass diffusion models, or 300 of SEIR epidemic models, or some other stuff. And so one of the funny problems that we were facing now, how to filter that out, right? So that's kind of good problem to have. Now, so you have that. This lock means that it's secure, and it's as secure as it's kind of. I always answer like we have. The security level is basic Amazon cloud security level. Would that be correct?
Yes, and we also use this HTTPS connection, and our models in the cloud run on separate sandboxes, so they do not see outside of their environment.
Okay. Now there's a public cloud subscription, so it's a very cheap option, and for a really small annual fee, what you get is you get your models executed in a different set of servers, which does not intersect with the public servers, right? And you have unlimited runtime, you have API usage, and access to external resources from your models uploaded to the cloud. This is what you have if you buy subscription. Now, there are two private cloud options, and there is full private cloud and private cloud lite with exactly same functionality, with the only difference that the bottom one, the lite one, only runs on one server, one node. And there is AnyLogic Cloud API that works for all kind of paid versions for subscription users and for both private clouds. And that API, currently we have JavaScript and Java, and we are releasing Python API very soon. Okay, and I think that this is kind of slide that is yet another view on the cloud. So one view, okay, it's a kind of YouTube for simulation models. Another view on the cloud, it's this. So you have AnyLogic model, which is essentially Java, and the engine is Java, right? Then we have this kind of AnyLogic Cloud backend, which does for you user management, version management, kind of upgrades, etc., input, outputs, data management, and run management, right? And on top of that, we have a web server, which provides the RESTful API. There was a question, I think this morning about the RESTful API. Of course, the web server of the AnyLogic Cloud does support this RESTful API. Then, on top of that, we have these things. We have default UI, YouTube-like UI. We have JavaScript API, and this morning during the workshop we showed you how it can be used to develop really customized and branded UIs. And then there are Java API and Python API, which you can further use to incorporate cloud-based models into your, let's say, analytical workflows, or like training environments for your neural networks, whatever. So in a way, you can treat the cloud as a wrapper around your model that provides multiple interfaces, which are easy to use and where you can choose different languages. Okay. Now the
So a few
architecture.
About, how our clouds are organized inside. So we have two versions for full cloud. So actually, cloud is a set of services which are interconnected to each other and operate in parallel. So there are different types of these services. Some of them are maybe created in several instances. For example, model executors, which are created dynamically when the cloud balancer decides to increase the number of parallel runs. So this is a full cloud where you can install all these pieces of the system on different machines depending on your setup on your local environment. And the light version where all these parts were put inside a virtual machine, which can be easily installed just in one click on your machine, and so it is suitable for running maybe simple and
it depends on the load.
Depends
you put
on,
it, yeah.
Yes, so they can serve multiple users, like a full cloud. So it depends on the tasks which are run on this cloud.
Okay, and these are some specs. Basically, what you get depending on what option you choose. So we went through subscription, and the difference between private cloud light and private cloud is only in the number of servers that are used by the cloud. So this morning we were running this thing, private cloud light, and we had here how many cores? 4 cores or
Today?
3?
So today?
This morning.
This morning we had 4 physical cores.
Yeah, and you saw the how it how it was working, right? So it's if you obviously that was just a laptop. If you install it on a server which has like 16 or 32 cores, the performance would be much better. Okay, now and the last, just to conclude with the cloud, some typical use cases for the cloud. Which we will just very briefly go through. So first, naturally the cloud is the execution environment for your models. If you are not going to throw away your model after you build it and ran and obtain some data, then you need to put it somewhere. And the cloud actually gives you the answer where the model lives after it has been developed, right? Next thing, if you're a consultant and if you want to leave the model with the client, again, you can export it as a standalone application and install it at the client side, but then you will have probably not straightforward process of upgrading it, of maintaining it usable because it's just a Java application, right? So one of the solutions is just install Private Cloud Lite maybe as a very cheap solution at the client side, and it's naturally your model will continue living there without any AnyLogic copies being purchased or installed at the client. Then, okay, multi-user access to the model, right? User collaboration. As you may remember, Cloud remembers all runs, all input-output pairs. So if maybe several researchers are running the same model with different scenarios, it will probably save some time and computational resources if they do that in the cloud. Because if somebody already ran a certain scenario, the results are remembered there, right? And obviously, cloud gives you some primitive but still version control. Now,
and of course, for have experiments when you have some Monte Carlo variation experiments, etc., which run the model multiple times, and the cloud is the best and possible solution. So these runs are parallelized on different machines, different physical machines, and the overall control on how these nodes machines are raised and how the tasks are sent to these machines is done by AnyLogic Cloud. So after these runs are completed, Cloud gets all this raw output information to the database, so you can easily get some statistics on this data and export it.
Okay, well, this may be a fairly rare case, but if you plan to sell your simulation as a service, as software as a service, right? Then you may consider cloud as a platform, right? And you can build a wrapper, like you can fully customize the UI, etc., as you saw this morning, right? So that is all possible, and it probably saves a lot of time. You don't have to develop the back end of your SaaS. Case number 6 is very straightforward. So there's a lot of research and development being done with neural networks these days, and especially with learning, deep learning, reinforcement learning. So, and which actually creates a completely new and very big application space for simulation models, because naturally you can use simulation models as a risk-free and easy-to-use environment to train your neural networks or to test already trained networks. So AnyLogic is the tool of choice for this particular case, just because first it's of its really versatile nature. You can create models of virtually anything with AnyLogic. Second, because it's very open, customizable, and has a lot of programming interfaces. So one of the options is to have a simulation model that you're going to use with your learning agent, to put it in the cloud and access it through the one of the interfaces that the cloud provides. But this is only one of the options. And then the last one, I was always against this before. So what is distributed simulation? Distributed simulation is all the simulations that you saw today and you would normally see if you go to a Windows simulation are not distributed simulations. They are sequential simulation. Basically, they, well, with some exceptions, they run on one processor, because what happens in the simulation model must be synchronized in time, right? So to run it on multiple parallel, to execute a single simulation run on multiple parallel processes, you need to know the structure of the model, and you need to be sure that those kind of threads may be executed independently, right? And previously, it was requiring a lot of kind of knowledge and coding knowledge to implement that, right? Now, with the cloud, you naturally can do it, because it gives you, well, basically the way you can do it, you can put, let's say you have a pandemic model with like cities where people infect each other in a city, which is intensive part, right? And you have flights between cities, which is rare communication. So you would like place models of your cities as separate models, different nodes, and then establish communication using the cloud API. So cloud, even that is now a lot easier to implement in the cloud. Well, that's all we wanted to say about the clouds. This is kind of history and the next steps. next steps are pretty straightforward. Python API is coming very soon. Administrator's dashboard, documentation and examples, but the main thing is that we will definitely need your input. Okay, how can we make the cloud better? What are the actual use cases? Maybe something that we don't know. So please do provide us the feedback. It's our kind of active development. We're eager to see your response and your requirements. So please stay with us and help us to make cloud really, really, useful and successful thing. That is basically it. So, John, questions?
Take questions real quick. A minute to a couple. Anybody?
Hey. Howdy. Two questions. One, you say 16 cores. Is that logical or physical?
Oh, that's for the private cloud Lite, the 16 or 32 core option. That's physical cores, right?
Yes, there's a number of cores on your machine which it provides.
Sure. So like I've got a 16 core processor, but it's got hyperthreading, so I have 32 logical cores. So how do you count the logical or do you count actual physical?
A cloud will give the load for 16 cores. So this may be like 16 logical or 16 physical. It will not utilize more than this number.
So we do not basically distinguish, right?
We do not distinguish, and
so you're not checking physical. You're just looking at the number of cores that are reported.
Yes, we. So this is actually like some limit included in the cloud.
Right. Do we check the number of physical cores? We don't.
We don't.
We don't. Okay. So that's
cool.
Yeah, okay.
Awesome. And then the second question is, do you provide webhooks or a control plane API for the private cloud so that you can auto scale? Like if I'm not running any simulations, I don't need a bunch of execution instances sitting around idling. I'd like to turn them off. But when I'm running the model, I want to scale up as needed. So do you all provide a mechanism so that I can do that programmatically, or do I have to do that on my own?
So by API, you are able to start running let's say, a simulation or a number of simulations or a parameter variation. Wait for all of them to complete, for part of them to complete. So basically, you're able to set up custom experiment with custom kind of scenario. Okay, run 10 simulations, look at the results, maybe run 2 others, change parameters, so all this sort of stuff, yes.
And the balancer of private cloud it has some politics settings like minimum number of execution nodes, maximum number, so it decides based on the load to start or to stop execution nodes.
So, but is there an API that I can call to find out like how many jobs I have running right now, so I can adjust my instances? Like, I don't want to spin up a bunch of compute instances that I'm not using. I want to adjust those on the fly.
So this is a topic of our development and administration interface. So we're currently doing this work in progress. So we'll currently have a page where you can observe execution instances and balancer, so how many tasks are currently running on each machine, view logs of these machines, and as for API for calling this from your code, it's currently not there.
Yes, currently the load balancing is R, right? Yeah. So we have load balancer in there, of course, and when you run, you basically rely on the load balancer that will do things in the right way, right? So, but yeah, thanks for suggestion. So there was, yeah.
Yeah, just a question on the API data. Is it only available after the simulation is completed, or is it a streaming kind of API where you can streaming data where you can get simulation details?
Right. Good question. Now, with the animation run, you have access to anything during the run, right? So you can stop it, you can call a function, etc. So, and originally we thought that a simulation run, like a batch run, should not have that capability. But now we're kind of implementing the same thing for a kind of animation-less run as well. So it'll be there because it's needed for applications like, well, for example, like reinforcement learning, right? So where you need to stop the model to run something else, provide input to the model, and continue running, right? So it'll be there, yes. All right, thank you guys.